Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create severed animal surface. In this video, I will explain how to use the parametric surface data function to create a brazier surface. This surface is a special case of pseudo-spheric surfaces. In physics, a brazier is a nonlinear wave in which energy concentrates in a localized and oscillatory fashion. The term of brazier comes from the characteristic that most braziers are localized in space and oscillate in time. The brazier surface discussed in this example is the pseudo-spheric surface that corresponds to a solution of a nonlinear wave equation. This surface can be simulated with this set of parametric equations. You can see here u and v are parameters. Here x, y, and z can be expressed in terms u and v. This equation also contains a constant of a. The a can take a value from 0 to 1, the range. Here u is in the range of -14 to 14, and v can take values from -12 pi to 12 pi. You can see these parametric equations are very complicated. Here we will use the Git tool to clone the source code used in the last video. Here is a download link at the GitHub repository. From this link, you can download all the source code used in the last video. Now open a command prompt window and run the following command: git clone and paste this link. This will generate a WebGPU 31 folder on your local machine. This folder contains all the source code used in the last video. Now we want to change the name of the WebGPU 31 folder to GPU 32. Rename GPU 31 to GPU 32 and cd into it. GPU 32. At this point, we are going to start Visual Studio Code with the command code period. This is a Visual Studio Code interface. Okay, we can close this welcome page. Here contains all the source code used in the last video. Now we are going to open a new terminal window and run the command npm install to install all npm package used in this example. This installation may take a while to finish, so please be patient. Okay, finished. Now all the installed packages are stored in the node module folder. Now we need to add the brazier function to the massfunc.ts file. From src folder, open massfunc.ts file. Here we need to add the brazier, the function. This function takes u, v, and center as its input arguments. Here the center parameter lets you set the location of the surface. Inside this function, we set the parameter a, the constant, to 0.4 because this parameter can take a value from 0 to 1. So here we take a special case equals to 0.4. Here we define x, y, and Z as a function of U and V use these parametric equations. This function returns vector 3 points on the brazier surface. Now we can save this file and close it. Next, we need to make some changes to the index.html file. From the dist folder, open the index.html file. First, we need to change here 31 to 32 because this is 30-second video. So we also need to change here the H1 title from Silver Pro to the brazier surface. The input parameters we use here will be the same as those used in the last video for creating the Silver surface. But we need to change the scale where parameter from 0.3 to 0. Okay, now we can save this file. Next, we need to make some small changes to the main.ts file. Open the main.ts file from SRC folder. Most code will be identical to that used in the last video here, except that we need to replace this Massfunc from Silver to brazier. Inside the create surface function, we also need to change the Massfunc to brazier. Here we need to use reset the parameter input here because the brazier, the U can take a value from -14 to 14, so -14 to 14. And we can take a value from -12 pi to 12 pi. The V division we can change it to 200, and V division we also take the 200. Now we need to reset X and Z value range from 2 to 6. Also, we need to change the scale Y from 0.3 to 0. Here is the default input parameter, so we need to change to 0 for the scale Y. Or the other part of the code is the same as that used in the last video, so we don't need to make any changes. With this framework set up and following procedure presented here, you can easily create your own 3D parametric surfaces in your WebGPU application by simply define your own parametric functions. Now we finish the modification to the main.ts file. We can now save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bundle our TypeScript code in production mode. npm run prod. Okay, the bundle file is created successfully. Now we can click the Go Live link from the status bar area to open the Chrome Canary to view our brazier surface. So click this link. Here is our brazier surface with default lighting and color map displayed on this page. Here the scale lets you set the default size of the surface. We can change it, for example, change it to 1. Click redraw. So we get a smaller brazier surface. So we set it back to 2. Here scale Y parameter let you set the aspect ratio. You can change it to any value you like. Next, we can also change the color map from this drop-down menu to recreate the surface with different color maps. For example, this is the default jet. We can change it to autumn, for example, brown, cool, copper, grays, hot, HSV, spring, summer, and winter. So we can set back to the default jet. You can see that in WebGPU, we can easily create a beautiful 3D surface with lighting and color map effects. Now we have completed this example. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.